It's been an exciting week so far. I hope you agree with me. And we're going to be talking today about packaging and alternative and functional packaging. And so I think Erwin alluded to it at the beginning. This session, I think this is an area where more work is needed, where we maybe haven't made as much progress as we have in some other areas. But I think every topic we've talked about, there's definitely work to be done. But it should be a good discussion. We look forward to the input from the audience, both online and here in the room. Remember, for those online, to put your questions in the chat, and we'll be monitoring those, and we will ask them during either after each presentation if time allows, or we'll do that at the discussion time. Grab my watch. Okay, so I'm going to be the first presenter, and I'm going to kick off the discussion here about packaging for produce. And you met me earlier in the week, but my name is Beth Mitcham, and I'm an extension specialist, and I also researcher in the Department of Plant Sciences. And my area is post-harvest biology and technology. And so I have worked in the packaging area a bit, but my expertise is in produce. So I'm going to talk about packaging, kind of the existing use of packaging and why packaging is important for produce and what characteristics we need packaging to have. All right, everybody has this. Okay, so basic packaging concepts. We need packaging to contain the items that we're selling. If we were trying to send them all separately, it wouldn't be very efficient. So we're trying to hold things together, but we're also trying to protect them from damage. And then, of course, packaging also provides some information to whoever the buyer is. But it's important that packaging be compatible with the cooling process. And also, a very important feature of packaging is to reduce water loss, and we'll talk a bit about that. And ultimately, we're wanting to maintain the quality till we get to the market, but potentially also extend the shelf life with the packaging that we're using. So I'm primarily talking about packaging for horticultural crops, so fruits and vegetables. These are products that have very high water content. They're fragile and easily damaged, but they're alive. Even though they've been taken off the plant, they're still living, they're respiring, and they start deteriorating as soon as we take them off the plant. There are a number of factors that contribute to the deterioration after harvest and eventual losses that might occur. And this is that ongoing metabolism, the fact that the product is living, it's respiring, it's producing ethylene gas sometimes. This is a natural hormone that plants produce that stimulates faster metabolism and also senescence or death. Of course, damage will increase the rate of deterioration of products, water loss, any kind of disease development. And then there are also some what we call physiological disorders. These are things that are not related to a pathogen, but can cause deterioration. And all of these different factors are affected by time and temperature after harvest, and that's why cooling of products is super important, and also expedited handling, particularly expedited cooling after harvest, because it's those times at high temperature that can be most damaging. But I would say that actually packaging can have an impact on many of these factors as well, as we'll see in the presentation. So when we talk about packaging for produce, we talk about the master container or the carton, and then we also talk about the internal packaging materials, which is oftentimes can include consumer packaging or packages. So for master containers, this is that outer box that holds everything together. The most common material is still corrugated fiberboard, also known as cardboard, but returnable plastic containers or RPCs are increasingly used and very common for certain retail customers. Expanded polystyrene is really on the way out. Maybe it's completely out at this point. Was very popular, especially for table grapes. And then corrugated plastic. Someone asked about this earlier in the week. This is the this white carton here at the bottom. It's very much structured like a cardboard box with fluting and whatnot, but it's made of plastic. They can be pretty flimsy from my experience, depending on how they're made. And then wood has been used over the years, but also very much phasing out, at least in the US and in Europe. So what makes a good container? Well, the container needs to be strong enough to support the product that's inside it, but also to allow for product to be stacked on top. Because of unitization and the need to handle products efficiently, we're creating pallets of product. And so we're stacking 10, sometimes even 12 boxes high, depending on the size of the box. So it has to be strong enough so that the product is not what's holding everything up. It needs to be the carton or the container. Needs to be clean, needs to be smooth so it doesn't cause any abrasion. Very important, especially when we're talking about the cardboard boxes, it's best if it doesn't absorb a lot of moisture. This can cause drying, but it has to be compatible with the cooling method. And we'll talk more about that. And then, of course, for marketing purposes, you generally want some kind of information on that box. It's going to say what it is, where it came from, and that can be a little bit of a challenge with things like RPCs, but people have come up with ways to get around that. So in terms of cooling methods, there are a variety of methods that are used for produce, and forced air cooling is pretty popular for many commodities. It's a rapid way of cooling with air, where you're pulling cold air from the cold room through the boxes of product. And we use an exhaust fan to create that negative pressure between pallets. And if the boxes are not sufficiently vented, this doesn't work so well. And so venting on the box is really important to allow that air to go through. And you need vents on both sides of the box. So if you look at this picture, this slide, you can see that these boxes are different. The one on the right-hand side, this pear box, has vents on all four sides. They're nice elongated vents, which actually work much better. This box on the lower right essentially has no ventilation whatsoever. So in terms of cooling, it's going to take much more time. Now, the RPC, you can see, has a lot of venting. So when they first came out, I remember everyone was very excited. Oh, these things are going to cool so quickly, and it's going to be great. But then we discovered that they actually have a little too much venting, and it can lead to water loss. So that's an issue. Yeah, so returnable plastic crates are growing in popularity, I think still today. They come in a variety of sizes. The nice thing about, well, many of them are collapsible so that they can be returned more efficiently, but that is one of the features here, is that to be reused, these have to be returned, washed, and then sent out again. So there's a whole infrastructure that works around that. And the other thing is the open top is a feature that's different from most other boxes. And they discovered that this could create some problems in terms of food safety, because when you start stacking these things, anything that got on the bottom of another container is now on the top of the one below it. So some people have used plastic shields to protect the product inside. Also helps to reduce water loss. With all that open space at the top, that could be an issue. So that's more packaging that's been added onto those to try to address food safety and also product quality concerns. So we've talked about this a little bit during the week. There's always these competing purposes, and which one is most important? Probably all of them, and you have to figure out how to balance it the best. So some boxes need to be water resistant because they are used in perhaps vacuum cooling with water spray. So they add water before pulling the vacuum, so that that water that's added is what is largely what is evaporated to cool the product rather than moisture from inside the product. So in this case, the box has to be able to withstand the water that is sprayed on it. So waxing is often used with cardboard boxes. Of course, RPCs would be water resistant. And icing is still used to some extent for certain commodities. I think it's slowly phasing out, but I think it's still being done for things like broccoli, one example. And of course, here the box does need to be water resistant because the slurry of water and ice is injected into the boxes, and so they get quite wet. So, of course, recycling of containers is something that we're very interested in, and because of sustainability, corrugated is pretty widely recycled today. The polystyrene and expanded polystyrene, they say that they can be recycled. I'm not up on the very latest on that, but the last I heard, it requires a very specialized process, and I don't know how readily available that is, or if it's even cost effective. Generally, wood is not recycled, but RPCs are. So if an RPC becomes damaged, so it can't be used anymore, it can be recycled by the owner of the RPC. Of course, reuse of containers is most popular with the RPCs. They're designed and managed for that. Requires a washing step in between. In the United States, other containers, I'm not aware of other containers that are allowed to be reused at this point, but during the discussion, if anyone knows of some, please do share. All right, so that's the external carton that we've talked about. In our next presentation, hopefully we'll hear about some new materials that could potentially be used for that outer material. But the inner packaging is maybe causing even more challenges, I think, for the produce sector. So the internal packaging material is used to help stabilize the product within the carton, to reduce damage. But very importantly, for a lot of commodities, it's used to reduce water loss. It may be used to modify the atmosphere around the product to help extend shelf life. And many of those internal packaging materials are display ready or consumer packages for the consumer to buy as a unit and then take home. So many of these are moisture barriers to reduce water loss. And so anytime you're using a liner like what you see with the kiwi fruit, or plastic packaging for things like peppers, those are primarily intended to reduce the movement of water vapor out of the product. For things like the bananas in the lower left here, this is actually a situation where we're modifying the atmosphere. So that plastic liner is intended to allow CO2 to build up inside that carton. So it depends on the package and the product. So I mentioned modified atmospheres a couple of times. I would like to just say a little bit about what it is and how it works, and how produce responds to it. So there's a lot of potential benefits of modifying the atmosphere around the product. This is generally where we're lowering the oxygen content and increasing the carbon dioxide content. It can retard the senescence or aging of the product and the ripening of the product. And it does that by reducing the respiration rate. It also reduces ethylene production. That's that hormone that promotes senescence and ripening. It reduces the sensitivity to ethylene that might be in the atmosphere already from other products. It can alleviate some of these physiological disorders that products can get. And it can reduce the growth of pathogens, particularly fungi, but sometimes also bacteria. So, normal air is mostly nitrogen, and we're generally trying to add additional nitrogen to replace a lot of the oxygen that's in the air so that we get oxygen down to a much lower concentration. And then we allow carbon dioxide to increase. And when we're talking about modified atmospheres, we're generally allowing the metabolism of the product to create that atmosphere for us. And I'll say more about that in a second. But I just wanted to show, here's an example of how a modified atmosphere, or in this case, this is probably more of a controlled atmosphere, but low oxygen and elevated CO2 has reduced the ripening of these plums that were stored for over a month at 10 degrees Celsius. And has similar effects on other commodities. And this is a laboratory experiment that's showing the effects on the growth of fungi in products. This is pomegranates stored under high CO2 versus air. And you can see that with 15% CO2, we've controlled the growth of the fungi as compared to in air. So, but in a modified atmosphere package, oftentimes we're counting on the respiration of that product, which is using up the oxygen and producing carbon dioxide. We're counting on that respiration to help modify the atmosphere inside the package. And then there'll be some type of a film, usually a permeable film, that has a certain permeability to oxygen, CO2, and water vapor. And then between the respiration and what's being produced and used up or metabolized by the product, and then that exchange rate through the film, you end up with an equilibrium atmosphere within the package. And so when these are designed, they're designed with all those factors in mind, including the temperature, the respiration of the product, the weight of the product inside there. All of that goes into consideration. So this is applied in various ways. So for these cherries on the right-hand side, they're basically just closing up this plastic bag. It can be tied off or a twist tie used, or you can do something more sophisticated where you actually pull a vacuum and inject some starter gas to kind of kickstart the process, and then seal it off and allow the natural modification of the atmosphere to continue. Sometimes an entire pallet is covered with a bag, and you get a modified atmosphere inside. In this case, with this Tektral system, they do pull a vacuum and introduce a high carbon dioxide atmosphere to kickstart that high CO2 atmosphere that helps to control fungal growth in the berries during shipment. So there's a lot of different films, and we're going to hear a lot more about this in the next presentation, but just to say that, there's a lot of science and development that goes into this with, there's single layer films, but there's also laminations and co-extrusions where you take different kinds of materials and blend them together to get the properties that you're looking for that are going to give you the conditions in the package that the product needs. Even some of this is related to water vapor transmission and fogging and other factors. So some of the requirements or some of the things that the produce industry thinks about when they're trying to select a polymer for packaging is, what's the oxygen transmission rate? You have to think about the size of the package, but also the style and the stiffness and clarity, the optics, like how easily do you need to see through? Usually they want pretty good clarity and visibility of the product inside. And then, of course, the topic today really is to get into, how many of these things are compostable, biodegradable? Can they have those characteristics and still have some of these other characteristics? And the reason we have to think about that is because we have an issue with plastics in the environment, and it's in the oceans, it's in the landfills, it's in all kinds of areas depending on the country. And So there's been a movement to ban single-use plastic in a lot of parts of the world, and a lot of interest in trying to come up with ways to reduce this problem, I guess I should say. But of course, I just told you how important and valuable plastic is for produce. And so that's the conundrum, because plastic is amazing in terms of reducing water loss and also for allowing for modified atmospheres in the package. So yes, do these packages, the biodegradable, compostable packaging, do they have the other features that produce needs? Are they cost effective? Are they truly degradable and compostable under usual conditions? That's a big question. There are a lot of competing needs in the packaging space. Of course, food loss and waste reduction is really important for sustainability, and everyone is cued into this right now. Are we going to have more food loss and waste if we change the packaging, if we no longer have plastic bags or plastic packaging? I already mentioned a lot of places have started to ban the use of these materials. I know at least in some places you can apply for an exemption for certain uses, but I don't know how easily you can get it. So really, I think one of the topics I'm hoping, and I believe is going to happen, our panel of speakers that are coming up are going to talk about, what alternative packaging is out there, and can these materials fit the needs of the produce, but also the environment, right? Because that's the challenge. All right, so we're going to have 4 speakers coming after me in this particular session, and I will just briefly mention that next up we're going to have Professor Gang Sun, who is here at UC Davis. I will introduce him in just 1 minute. He's going to talk about materials science and help us understand some of these different materials and some of their advantages and disadvantages. And we're going to hear after that from Professor Nitin Nitin. He's going to talk about some functional packaging. And then we'll hear from 2 individuals who are in the industry working with alternative materials and also alternative ways of dealing with some of these compromises that are being required in the packaging space. And so that'll be Mark Buell from Data Harvest and Felipe Ilanes from Tres Castillos. So we have a great session lined up for you. And I guess before I introduce the next speaker, I'll ask if there are any questions related to this presentation before we move on.
Hi. My question is about the modified atmosphere in packaging. Do you see exponential growth on packaging once the modified atmosphere is removed versus not a pallet that didn't have Teflon, for example?
That's a question I get so often. Usually there would not be exponential growth, and most studies have shown that there's usually a little bit of a lag before the fungi starts growing again. But I can tell you that those atmospheres don't kill the fungus. They only keep it from growing or slow the growth. So the fungus is set to grow again once conditions are favorable again.
But by using the Teflon, the long-term development of the pathogens are until it is better overall.
Yeah, absolutely. I mean, it's going to gain you however many days you had it under those conditions. It does, though, speak to the fact that if you had a consumer package with that atmosphere that could go all the way into the household, it would give more protection to that product. If we could figure out how to, I think they're working on some products like that in Europe, I believe, with lidded and modified atmosphere packages.
Hi, Beth. Thanks for your talk.
Hi.
I have so many questions on the water spray cooling, probably more than we have time for now, but a quick one is, if you could just say a little bit more about that, like if you're doing the water spray versus just vacuum cooling, is it like fog that's being added to the chamber and spraying the top of the produce. And I guess I'm just curious a little bit more how the science of that works, because from my understanding, like you actually, if that latent heat of vaporization out of the produce that's cooling it, so if you're just actually evacuating water from the air and not the product, you're, I guess I'm confused that you're still getting the cooling effect in the produce.
Okay, so I may have to get Erwin to help with this one. We're getting into engineering concepts, but yeah, it is a spray that's coming down on top of the pallets of water droplets.
So a couple of things here. That's not related to packaging, but the question is related to vacuum cooling. Vacuum cooling is the method that is very typically used in the leafy green industry to reduce the temperature, to quickly reduce the temperature of the product. And there's two methods of vacuum cooling. I'm just giving a little bit of context to this question. There's a method that they add water before the vacuum cool. And the reason why they add water is to reduce the moisture loss of the product. Yes, it does have an effect. That said, you cannot have liners or any packaging that interferes with this. You need to wet the product itself. So there cannot be any liner or anything that interferes or that blocks the ability of basically having that contact with the chamber, with the vacuum cooling chamber. What it does is it creates almost like that film, like a small film around the product, and it allows that cooling to start because that's the first layer of water that evaporates before we're removing moisture from the product itself. So it does give you a couple of degrees of reduction. That said, there is still some evaporation that is happening from the product, so you cannot reduce that completely. I don't know if that answers your question. Yes. So again, like one of the misconceptions of vacuum cooling is that really, if the package, the liner is acting as a complete barrier, if there's no gas interaction, you will literally pop those packets because once water starts to evaporate, it needs to find a way out. See, so it's any package that you do not exhibit that, any package that has the ability of basically having that gas interaction, water vapor mainly, the vacuum cooling is going to occur. So in some instances, they do use some perforated plastics as liners in vacuum cooling, but it's rare. They try to avoid that. The only way that they're doing it is they're basically wetting the boxes, and that's another thing. When what we have found, or what's not what the science has determined, is that a lot of the moisture loss of the product is actually when the moisture goes to the boxes themselves, to the cardboard. So by you wetting that cardboard, you reduce that moisture loss too. It starts evaporating from the cardboard itself. So that brings different layers, different problems. It's not, you lose the structure of the boxes too. So strategically speaking, vacuum cooling, it does require a little bit of tinkering, if you think. So, but it's again, it's not related to the packaging. It's more related to the produce chamber interaction.
Okay, so we had actually a question comment in the chat from Felipe, who's one of our speakers coming up. And he was commenting when I said we could do potentially MAP for consumers. He's bringing up the point that you're going to you have more issues with temperature management when consumers have an MAP pack, and that's true. But and that happens with lettuce and whatnot. So the package would have to be designed with that in mind. So maybe you would have to. Maybe you're trying to achieve 10% CO2 or 8% CO2 under cold conditions so that if they do abuse the temperature, you don't get into injurious CO2 levels in that package. So when you design a package, you have to keep in mind what temperatures might be experienced, and it's a compromise. You can't go with the absolute optimal atmosphere generally. All right, I see Marita has a comment. We're gonna get that one, and then we need to move on because we're a little over time.
You just raised the big T word, right? Temperature. So I may have missed it, but I just want to hear a very clear statement about the relative importance of temperature versus the packaging in terms of the modified atmospheres.
Absolutely,
So everyone's
yes.
clear.
Yes, let me be very clear. For produce, yes, the number one factor that affects the deterioration is temperature, and especially those higher temperatures at the time of harvest. So getting the product cool and then holding it at the optimal temperature is the single most important thing you can do. Next would be reducing water loss. And then we get into modified atmospheres. Thank you, very important. Okay, so
Sorry, but one thing,
Uh-huh.
because I want to give a little bit of homework to those who use packaging here, and you know who you are here. I want you to think from now to the time that we have this session, what is the most important thing for your packages? And I'm just going to give you a little hint. In many instances, what I've seen, the most important is appearance. But that doesn't mean that it's the proper package for the produce. Just a little bit of food for thought. But just make a list, and then just transfer to us what is the most important characteristic of your package, at least for you or from your clients, or and that would bring a nice discussion.